So here we go with lesson 36. This wraps up section 4.5 with rational functions. So as we wrap up this section on 4.5, we're going to be discussing a slightly new topic. And so here's our first equation, x squared minus x over minus 6 over x squared plus 3x plus 2. Let's factor the numerator and denominator, and I'll talk about that new topic. So we factor the numerator, x minus 3x plus 2. We factor the denominator, x plus 1, x plus 2, and notice what happens here. We have a numerator and denominator that have the same term, which we're going to cancel out. So let's see what happens when this goes on. So we end up with x minus 3 over x plus 1. So we're going to end up we're going to end up graphing that equation. But look at the original equation. The original equation has an x plus 2 in the denominator. It had one in the numerator. So x equal negative 2 will not be an asymptote, it'll be a hole. There'll be a hole in the function. We're going to graph f of x equals x minus 3 over x plus 1. However, we have to pay honor and homage to the original function, which did not allow x to be negative 2. So we're going to graph x minus 3 over x plus 1 with a hole at x equals negative 2. And this should look familiar, except for the whole part of it. We're going to find the horizontal and vertical asymptotes. We're going to find the x and y intercepts. We're going to say, does it cross the horizontal asymptote? And then I added f here. Find the hole in the graph. There'll be a little hole in this graph because you can't let x be negative 2. And then we're going to sketch the graph. Let's get busy. So there's a lot on this screen. Horizontal asymptote. X on top, x on the bottom. So they tie. The ratio is 1 over 1. So horizontal asymptote is y equal 1. Vertical asymptote, there's only one. X equals negative 1. Can't let x be negative 1. I know we can't let x be negative 2, but that does not create a vertical asymptote. That's just a hole in the function. We'll talk about that in a minute. X-intercept, we want the numerator to be 0. So if you let x be 3, the numerator turns into 0, so the whole thing is 0, and it crosses the x-axis at 3, 0. Y-intercept, just put 0 in for x, and you get negative 3 over 1, which is negative 3. Does f of x cross the horizontal asymptote? So we set the function equal to 1, multiply both sides by x plus 1, and you see you have x minus 3 equals x plus 1. You cancel the x's, and you get negative 3 equals 1, which makes no sense whatsoever. So no, we don't cross the horizontal asymptote. And now for the new part. We can't let x be negative 2 because of the original function, but x minus 3 over x plus 1 is perfectly fine with a negative 2. So we have to find out what value gets returned when you let x be negative 2. Right, so we put negative 2 in for x, you get negative 5 or negative 1, which is 5. So there's a hole in the function at negative 2, 5. And we'll just put that in the function here in a minute. But we won't have a vertical asymptote at x equals negative 2. That's where you go up to infinity or down to negative infinity as you approach. There'll just be a hole in the graph. Let's sketch it out. So let's put in what we know. We have a horizontal asymptote at y equal 1. We have a vertical asymptote at x equals negative 1. We have an x-intercept at 3, 0, a y-intercept at 0, negative 3. We do not cross the horizontal asymptote. That's nice to know. And there's a hole in the graph. Look up there at negative 2, 5. We just put a hole up there. And now we're going to sketch it. I think I got the first region figured out, and I think I got the second region figured out. Because we got to skip over that hole, and we can't cross the x-axis in the first region. I think we got this. So I just don't see any other possibility here. We have to come in hugging from the left, hugging the horizontal asymptote from above. We got to go over, skip over the hole. Even if we didn't know the hole was there, we'd have gone up because we can't cross the x-axis, so we couldn't be below the horizontal asymptote and going down. And then the second region, we got to go through those two intercepts, the x and y intercept, and so it has to be below. And again, as we leave the page to the right, it's got to be hugging the horizontal asymptote. So again, as I always say, show me another option that works. There you go. Let's move on. So we have x squared plus 1, x plus 4 on top. We can't do anything more with that. X squared plus 1 cannot be factored. On the bottom, we got x squared plus 3x minus 4, which I think we can factor, and x plus 2. Let's move on. So we factor it out, and we notice that we end up with an x plus 4 cancels out on top and bottom. So we're left with x squared plus 1 on top, which is not factor, and we have an x minus 1, x plus 2 on the bottom. So that's what we'll graph, but remember there has to be a hole in the function at x equals negative 4. So we'll be plugging that negative 4 in to see what happens. But before we deal with the whole, let's get some basics out of the way. Horizontal asymptote. If you FOIL out the denominator, you'll see that you have x squared on top and x squared on the bottom. And so we go to the tiebreaker, so the horizontal asymptote is y equal 1. In the denominator, I have x minus 1 and x plus 2. Therefore, our vertical asymptotes are 1 and negative 2. There is no x-intercept. Look at the numerator. There is no value of x that turns x squared plus 1 equal to 0. You can try all you want. It'll never happen. We will never cross the x-axis. Y-intercept. Put 0 in for x in the function, and look what happens. You end up with negative 1/2. So we have a y-intercept at 0, negative 1/2. Does the function cross the horizontal asymptote? Set the function equal to 1, what's left of the function, multiply by the denominator, and you'll notice the x squareds cancel out. The lead terms always cancel out. Add 2 to both sides, and x equals 3. So we have a horizontal crossing at 3, 1. Find the hole in the graph. Here we go. Set the negative 4 into the function, work it out, and you get 1.7. The hole is at negative 4, 1.7. So let's put some of these basics in. We put the horizontal asymptote there at y equal 1. We put the vertical asymptotes in at x equals 1 and x equals negative 2. There's no x-intercept, so let's not put that in. The y-intercept, I put that in at 0, negative 1/2. And then I put the crossing in at 3, 1. You see there on the horizontal asymptote, I have a crossing, a dot at 3, 1. And then I put a hole at negative 4, 1.7. So at negative 4. Then I go up to about 1.7. I stick a hole there. There we go. Now we're ready to do some graphing. So there are 3 regions. The first region is pretty obvious for 2 reasons. We have to get through the hole, or skip over the hole, and there's no x-axis intercepts in that region. So we have to be above the horizontal asymptote, heading up. Let's move to region 2. Again, not a lot of decisions here. We have to get through that y-intercept. We cannot cross the x-axis, because remember, we're never crossing the x-axis in this one. And so it's some kind of parabolic thing there. You don't have to draw me a perfect parabolic, and you don't have to plug a bunch of points in. That's good enough. Let's move to the last region. And again, not a lot of decisions to make here. We've got to go through that point there at 3, 1. We can't cross the x-axis, so we must be coming from positive infinity straight down. We cross over, and we spend the rest of our life trying to get back up there. So this is a decreasing function to a point, and then it starts increasing back up. We did it. Well, now we shift gears a little bit, and I've got 4 problems here for you, and you're going to like these because you don't have to graph anything. And so let's come up with a rational function that makes all this true. Vertical asymptote negative 5, horizontal asymptote y equal negative 2, and an x-intercept at 4. And so the vertical asymptotes go to the bottom. And so x plus 5 must be in the bottom. That's why the vertical asymptote is x equals negative 5. X-intercepts go up top. And since we have an x-intercept at 4, we must have the term x minus 4 up top. So x-intercepts up top, vertical asymptotes on the bottom, and they're always the opposite. Now the horizontal asymptote is negative 2. So because the horizontal asymptote is not 0, then we know the degree on the top and the bottom must be the same. So we just stick a negative 2 out there. You're going to like it when the horizontal asymptote is not 0, because life is pretty darn easy. There we do. There's an infinite number of answers here, but this is the easiest one you can find. Let's go to a little harder one. Well, this has got a little bit more in it. We got 2 vertical asymptotes. We only have 1 x-intercept, and the horizontal asymptote is 0. That means the degree of the denominator will be bigger. In other words, there'll be more terms in the bottom than we have up top. And if you let x be 2, it better return a negative 11. So we have a little bit more work to do on this one, but the basics are still there. So vertical asymptotes go to the bottom, x minus 3x plus 2, always the opposite. X-intercept goes up top. There's only one of them, and that's 9, so x plus 9 up top. Now, because the horizontal asymptote is 0, then we really don't know what that coefficient is. And so this is where we're going to use that plug and chug. We're going to let x equal 2. We're going to set the function equal negative 11, and we're going to solve for that coefficient. So I stuck a b there. You can put any variable you want, but I put a b in there for now just to play that placeholder. I'm going to plug 2 in for x, and I'm going to set the function equal to negative 11. And I'm going to solve for b, and we'll be done. So we have 2 plus 9, 2 minus 3, 2 plus 2. Set it all equal to negative 11. What's that going to have? An 11 up top and a negative 1 times 4 on the bottom. Oh, yeah, I guess that's right. So we ended up with 11b over negative 4 equals negative 11. So I multiply by negative 4 and get 44 equals 11b. So b is 4. And that's all we were missing. We're ready to wrap this one up and move on to the next problem. And there you go. Vertical asymptotes on the bottom, x-intercept up top. We have a coefficient of 4 there. We have a horizontal asymptote of 0. If you let x be 2, it'll return negative 11. We got it. Let's move on. Well, this one's got a hole in the function, so there's a little bit more going on here. But you know what? There's the same number of vertical asymptotes as you have x-intercepts, and the horizontal asymptote is negative 3. So really, this is going to be a lot easier than the previous problem. Let's hold off on the hole right now. Let's just get the basics in. Vertical asymptotes go to the bottom, x minus 5, x plus 2. Horizontal asymptote, let's not worry about that. X-intercepts go up top, x plus 6, x minus 7. Tack the negative 3 in there up front. All we have left to do is pop in the hole, and that is x minus 1 on top and bottom. And look, it's all there. Vertical asymptotes on the bottom, x-intercepts up top. We have a tie, so we have negative 3 out front there, and we have negative 1 on top and bottom. And leave it there, because you got to leave the hole in the function. One more, and we're done. Well, this one's got it all. 2 vertical asymptotes, 1 x-intercept, a horizontal asymptote is 0. We have a hole in it, which I'm going to leave to the very end. And if you let x be 5, the function will equal 3. So let's get the basics in first. So the vertical asymptotes go on the bottom. The x-intercept goes on top. I stick a b in there for my placeholder for my coefficient. I then go and plug 5 in for x, set the function equal to 3, and I get 3b over 6 is equal to 3. So you get 18 divided by 3, b is 6. So we have everything except the hole. So b is 6. Next up, we're going to put this all together. Put the 6 out front there, x minus 2, x plus 9 on top, x minus 4, x plus 1, x plus 9 on the bottom. Vertical asymptotes on the bottom, x-intercept up top. We got the hole in there, and we have a horizontal asymptote of 0, and the coefficient out front is 6. There you go. We did it. And that wraps it all up. That wraps up lesson 36. Get to work on the homework.